Should be ready. Okay, we should be ready. Okay, now we have a new topic. So far we covered just one single design pattern, okay, iterator. So that one is more about like a warm-up for the rest of the design pattern we're going to talk about. Another simple one, the Singleton pattern, but later on after the reading week, we're going to see the more complicated ones, which require intensive use of inheritance. That's something we'll do before the reading week to do some review. But today, let's do something light. Singleton, okay? Those of you who took 2030 with me, we didn't actually do Singleton. But for those of you who did 2030 with somebody else, did you do Singleton in Java? Okay, if no, that's fine. We'll learn it, okay? I'll actually show you how you can do in Java versus how you can do in iPhone, just to do a little bit of comparison, okay? Again, as I said, always, in order to introduce you about a design pattern, let's see what the problem is, okay? So now let's say we got bank accounts, okay? And somehow the bank account, they share a set of data, okay? It could be what should be the minimum balance, what should be the maximum balance allowed in that particular bank, and what should be the interest rate, and what should be exchange rate. And one thing to note, these things, especially interest rate and exchange rate, they change all the time, okay? They are not stable, okay? That's one thing to note. And the second problem could be a little bit like an OS problem, operating system. You got processes, and you have to somehow regulate concurrent access to the data. Okay, that's something you want to. For example, if you got only a set of printers, you want to make sure the printers can be shared among different processes. Okay, that's another problem. It's two different kinds. So now let's just consider the problem for bank accounts. You can certainly generalize to the processes problem as well. Let's consider the first design, the first one. Okay? Typically, the first one or first few ones I give to you, they are not good usually. But we're going to see how we can make sense out of them. Let's say we have a class called deposit. And notice that the deposit class has a superclass called share data. So we'll see what share data is in just a moment. We got another class called withdraw. Also extends from or inherits from share data. Also, we got another class called international transfer. Also, they got to share data. And notice that for deposit, you only worry about what should be the maximum balance allowed for the bank. You don't really worry about the minimum, would you? Right? Because you're adding money to your balance, right? On the other hand, for withdraw, you only worry about the minimum balance allowed rather than maximum because you only subtract. For international transfer, you only worry about exchange rate, let's say. So basically, each descendant class or each subclass of shared data, they only worry about certain parts of the shared data. For example, you can see deposit, we don't really worry about exchange rate, right? Similarly. Okay, finally, we have the class called account. Each bank account, normal accounts, they should have some deposit list, also withdrawal list. That's similar to what you learned in Lab 0. Similar. Okay, that's from the descendant side. Let's see how the share data look like. Basically, share data is more like a union of everything that should be made available. You can see for share data, we have interest rate, we got exchange rate, minimum balance, and maximum balance, right? That's the first design. Okay? Now the question is, do you see any problems? And typically, when I say problems at this level, I don't mean compilation problem. That might be the question I will ask you in 2030. But now here, it's more about design decision. Okay? Think about it before I give you two hints. Okay? There are two design principles we're going to go over to actually see the Singleton pattern. Okay? But as far as you can see, do you see any potential flaw for this design?
That each class can modify any of the shared data.
Okay, I will go with your thought. You're trying to say every account over here, let's say deposit or withdraw, they can actually modify interest rate, exchange rate, right? However, are they modifying a shared copy or their own local copy? Okay, what do I mean by that? Okay, let me just give you a little bit illustration over here. That's actually one of the things we have to worry about. So now let's say, for example, let me switch to iPad. Let's say deposit and withdraw, right? Okay, so now let's say we got deposit at the runtime. So now I'm talking about runtime. At runtime, let's say I have an object of type deposit versus I have another object of type, let's say, withdraw. Okay, just withdraw. You can think about other classes as well. Okay, question number 1. According to the design over here, how many attributes should the deposit object possess? How many attributes? Are you sure it's only 1? Aha, 1, which I put in comment, is to say we only care about that particular one. However, it's about inheritance. You inherit everything from your parents, basically, right? So there'd be 4, which means we got interest rate, exchange rate, minimum balance, and maximum balance, right? Similarly, we also get 4 attributes for withdrawal as well, even though, for example, let's say interest rate, exchange rate, and also maximum balance, they are not so relevant, but you still inherit them. Hopefully you already see what's going on here, right? Something that not so consistent here. Okay, let me just do a little bit more illustration over here. So now basically every object here, we got 4 attributes: minimum balance, maximum, maximum balance, interest rate, and also exchange rate, right? Similarly, for withdrawal, we also got minimum balance, maximum balance, interest rate, and exchange rate. The number here is not so important. I want to see the structure. And notice that, as I keep repeating, as far as deposit is concerned, we only worry about the maximum. Okay? As far as withdrawal is concerned, we only worry about minimum. And the other attributes are simply not relevant. Okay? And now, that's one thing. But now go back to your original thought. If, let's say, I go for this particular object over here, let's say deposit, right? Let's say it's deposit 1. If I say D1 dot, for example, somehow set the maximum balance, let's say there's a bank policy. I want to set a maximum balance, for example, to be, let's say, for 1 million, let's say. So now, by setting this, before I do that, let me do a small setup here. Let's say at the moment, the maximum balance is simply just, let's say, 10,000, let's say. Before we try to do a setup in the blue. So now, as soon as I do D1 that set maximum balance, am I going to create any inconsistency here? Well, I hope you can see that it's quite obvious, right? Because now, when I use D1 that set maximum balance, what they will do is it will simply modify this particular local copy and change that to 1 million. Right? Because we only worry about the context objects. We don't worry about globally all the bank-related objects. Right? So you already got inconsistency. 1 million versus 10,000, so you already got inconsistency. What you could have done would be, maybe when you set up the balance for, let's say, set a maximum balance for deposit, you have to somehow go across all the existing objects in the memory. And then if there are deposit, withdrawal, or any bank-related type, you can set it. But that'd be quite costly, wouldn't it? Right? You're setting many copies. Okay? So now, one thing to note, basically, that already says one of the problem. Maximum balance, we have already 2 copies of them. So that's why, to really keep them consistent, you have to maintain them, right? So many copies to maintain. And this violates one of the policies, okay? One of the design principles. We'll get there. Any other problem you can see? So sharing is not achieved so easily by this example over here, because every bank-related objects, they have their local copy of the interest rate, for example, right? Can be done, but not so conveniently. Any other problem over here? So sharing is a problem. That's number 1, right? Number 2. Yes? You wouldn't need all the features. Give us one example. For example, let's say for deposit. What's wrong with deposit over here?
Well, deposit doesn't need minimum balance.
Yep.
Doesn't need
Exchange rate doesn't need interest rate, exactly. Okay, so now that's something, okay, that's exactly right. So Michael just pointed out over here, you can see for deposit, we only care about maximum balance. All the other ones are not so relevant. If something that's not so relevant in your particular class, you shouldn't include them. That's the design principle for the class. You want to include everything that's relevant to this particular class only. No more, no less. So now, let's counter the criticism for this design, right? Basically, what I just tried to do is to criticize about this particular design. Simply put everything you want as a union into the superclass and let all the child class to inherit. That might be what you would have done. Okay, but that's not good. It violates two principles over here. Okay, let's talk about it. Okay, so now that's a nice example here. So one is called cohesion. Cohesion simply means you want to keep only consistent data in a particular class. Okay, in this case, you want to make sure, for example, in the deposit class, in the deposit, only maximum balance should be included. Everything else will be inconsistent, right? Because that's not the concern of the deposit. That's cohesion. Number two is a single choice principle, right? Again, we got single choice principle. Single choice principle simply means each kind of data should only exist in the minimum number of places possible, which means whenever you want to change that data, you will simply go to that minimum number of places. Okay, let me write it down, and then I'll illustrate that to you. Okay, we'll see a single choice principle so many times in the class, right? Basically, every design pattern, when we show you the best solution, almost all of them violate the single choice principle, right? Basically, whenever you see duplicates, that means you got violates. Okay, single choice principle. Okay, I believe you'll see some definition in the slide, but I'll just explain to you in my words. Okay, basically, you have to say when a kind of information is duplicated in multiple places. That's kind of the observation. Whenever you see that there's a particular thing that's really the same, but it's duplicated in multiple places, that means you violate the design, single choice principle. But the consequence of this is when there is an update, when there is an update on the information, you have to update multiple places rather than a single one. Okay? Okay, that's single choice principle. Blue one simply tell you how you can tell you're violating the principle. The red one tell you how bad it is. It's just hard to maintain. Okay? Okay, it makes it hard to maintain. So typically what I'd like you to do when you submit the report for your end of semester projects, I would like you to reflect on your own design, to think about, are you really satisfying the single choice principle? So you're going to examine your code from beginning until the end to see if there's any duplication over there or there's none, right? That's something you want to think about, right? Do some self-evaluation. All right, so that's about single choice principle. Again, over here you can see that every time if we want to modify the maximum balance, for example, I got to go to this place and this place as well. It would be very nice if there's only a single place where we store the maximum balance so that as long as we update just one of them, just update that single place, everywhere else can be reflected. Now, let me give you a little bit analogy. Okay? Can you somehow link the concept called aliasing to single choice principle? Aha, okay. Okay, anybody want to try? How are they similar? Anybody want to try? Jordan.
Change alias, and then it will change everywhere.
Change it everywhere.
Variable that will represent.
Yeah, because all the variables are referring to the same objects, right? You just change a single object. Okay, let me just, for those of you who are not getting it, I'll do a very quick illustration. So, same idea, okay? So now imagine that if I got point, let's say points are two-dimensional points. I got P1 is, I'll just write Java, okay, for you. Some new points over here, and then I say points P2 is assigned to P1, and then I say points P3 is assigned to P2. Okay, so now if you think about this kind of scenario, right, and then after this, if I say P2 dot set point, okay, let me get more concrete for you. Let's say over here, I simply got, let's say 2 and 3, okay? So now, just for the blue part, okay, I'll complete the red part in just a moment. For the blue part, would you agree there's only a single object being created, right? Just a single new keyword. In IFO, just a new single creates. Let me just draw it very quickly. So you got a point object over here, and then you got X and Y being 2 and 3. And then P1, P2, and P3, they all store the address of the same objects. So conceptually, they're pointing to the same objects. They all depend on a single object. Okay? That's a phenomenon. Okay? Whenever you see something similar in your design, which means multiple places are depending upon a single place, that's a good sign, right? Because you're not duplicating. So now the red part, just to say, red part is about whenever there's an updates on that shared data. So when you say P2, that's set point to be 4, 6, right? After this, if I simply say what's going to be P1 dot get X, and also P1 dot get Y, am I going to get the updated value or the old value? Updated, right? Because after this, I simply get 4 and 6. And now, because they all point to the same object, so it doesn't really matter. So it's only a single place you got to modify. Right? Just drawing a little bit connection to 2030. Guys, is it clear? Okay, very good. Okay, single choice principle. It's not difficult, right? But you see that a lot. All right, so now after this, what we would like to do is to talk about how we can solve this problem here using some interesting construct. Okay, we'll get there. Okay, that's exactly what we just said, cohesion and also single choice principle. Yeah, that's exactly what I just said. What if there are changes, right? You got to change multiple places in the original design. Okay, so the solution right now, let's lay out the solution. And I want you to think about, is it possible for you to achieve that solution? Okay, so that's the ideal solution. Okay, the ideal solution should be, number one, we want to somehow separate the notion between the data and the shared access to the data. So what do I mean by that? Basically, you can think about what I really want to have later is to think about, I want to have one class over here just for my bank data. And then I want to have just another class separate because somehow the access versus the data itself, they belong to different concept. And then I got bank data access. Somehow they're simply two separate classes. That's what I want to achieve. Okay? So the idea is we want to maintain cohesion. It is to say data and their access belong to different classes. Okay? One is about the data themselves, like interest rate, minimum balance, maximum balance, but access just about having a single instance of that particular data. So a different concept over here. We want to decouple them into different classes. Okay? Question for you, before we see Java code a little bit later. How would you achieve this in Java? What keyword would you need? Package, maybe not. Static. Okay, I heard static. Static, that's good. Every time you want to have something that's global to all the objects, you want to use static. Okay? It might be hard for you to imagine. My mini conclusion for you, you can challenge me later. We're going to see that a little bit later. We're going to see that in order for you to separate the two concepts into two classes in Java, you run into some design flaw as well. Okay? Just keep that in mind. Okay? We'll see examples. Before that, I just want to introduce you to some concepts you should know for iPhone. Okay? And then we'll compare the two designs in just a moment. Okay, so we want to encapsulate the shared access itself into a separate class. Okay, that's the idea. Okay, so now we're going to introduce something called once routine. Okay, the idea is not so difficult. It's just a little bit weird at first. Okay, before I'm going to show this code to you on an iPad, and then we'll talk about it. Okay. Okay. So now let's go over that. Okay, quickly. So now I want you to look at, first of all, on the supplier side over here. We simply got class A with some constructor. Okay. And then we have two different queries. Query number one, we simply say new once array. For query number two, we say new array. Did you already notice a difference between these two queries? Can you see the difference? Once, right? Well, I highlighted for you already, right? Once over here versus do over here. Basically, up to now, every time you define a feature routine, including what you're going to do tomorrow, right? You will simply just do. You just do over there. However, now we have another possibility. We'll simply just get once. Okay, so now what difference is it going to make? That's the question. Okay. On the other hand, you can see if you compare these two queries, the body of implementation look basically just identical, right? We simply create some empty array, and then we simply force an element into it by the parameter over here, right? You can see we're giving s, we're trying to force s to the end of the array. And also similar, we give an s, forcing that to the end of the array. The only difference really is once versus do. So now we want to know what's the difference. Okay? In order to see its difference, let's compare two tests, and then you will see. Okay? So now, before we do the once version, let's do the non-once version, normal version. Okay? Let's see. So we'll first of all do a query over here, test query. And the next one, we're going to do test the once query, right? We'll get there. So now, let's say we have an array A, and also we have, we got class A. And also we got array 1, array 2, array of string. Okay? You shouldn't be too surprised if I simply say ARR1 is assigned to a.new array. So I'm calling this feature over here, new array. Okay? So now, what kind of array do I have? Of size 1? Would you agree? Because you can see over here I'm passing Alan. So this will just be Alan. Right? So what I will get is ARR1 is now going to point to an array. Indices start with 1. And then index 1 is simply storing the string Alan, right? I'm just forcing Alan to the end of the array, right? Forcing it. Any question? Nothing new. Nothing new. Yeah, it's just a string. It's an input string. You want to force to the end. So over here, so this part over here, result account plus 1, simply means the following. Okay, I'll give you one example. Okay, that could be useful for tomorrow as well. Let's say if you have an array A. A is pointing to, let's say, an array like this. Okay, just give you one example. Let's say it's A, and also B, and also C. Indices are simply 1, 2, and 3. Okay? If now I say A dot force, I want to force D to the end. So now, which index should D go to? 4. Well, what should that be? A dot count plus 1. That means, yeah, we're going to grow the size of the array dynamically, so it's going to be 4. And then we're going to insert D into it. Right? That's a pattern you would have seen already for many times. Okay. Okay, so after this, we're going to have result. It will simply be count of the array will just be 1, and also AR1 will just be Alan, right? No problem. Okay. Now, the second one. Let's say we got another one, ARR2, just another array. So ARR2 is going to point to some array. What should that be? It's going to be the return value of a.new array, and then we'll say mark. What should that be? What? Yeah, just create a new array, right? Just a new array of size 1 as well. Okay, agree? Okay, you notice that we always create an empty array to begin with. It's kind of odd routine, but I just want to illustrate to you. Okay, so that means ARR2 is going to point to another new array of size 1, and that one is simply pointing to Mark. Okay, that is why you see ARR2, the count is 1, ARR2 at position 1 is Mark. And also notice that ARR1 and ARR2, are they the same array? No, that's why you say not the case. Any question about this? Okay, what you're going to see is, next slides, we're going to run basically the same test, except that rather than calling a.newArray, we're going to call a.newOnceArray and see if outcome will just be the same. They shouldn't be the same. Otherwise, what's the point of having ones, right? Let's have a look at the next slides. So that one's going to be a little bit shocking to you. Could be. Okay, so far I'm assuming you're okay, right? Let's go to the next one. Okay, this is absolutely clean. So now what we are doing is we are trying to test once array. So what we are calling is this particular feature over here, new once array. And notice that we got once. Okay? I'm not going to tell you exactly what once is going to do, but I'm just going to show you what's going to happen. Again, we create an object of type A, and now ARR1 is going to be, I tell you what, the first time you call this once query is going to be exactly the same as the do part. Okay, just the same. So now, okay, let me notice one thing here for you. A.new once array. This is the very first time of calling this once query. Just the very first time. In which case, you're simply just going to execute the body of the code over here. Well, create an empty array, insert to the end. In that case, you're just going to have ARR1 is assigned to an array of size 1, and then it's going to point to Alan, right? Okay, and this test is just going to pass. Same as before. Okay, so far so good. Now let's say we already called it once. Let's call it a second time, subsequent time. So now if I go for ARR2, should ARR2 point to a new array? No. Ah, you guys are smart. That's good. Otherwise, it would be the same behavior, right? Okay. Okay, here's a trick. For the very first time, you try to execute a once query or once command, typically once query. Only the very first time, you're going to execute the body of the code. After the first time, you're going to somehow cache the reference for the return value. And then later on, all the subsequent times you try to call the same once query, you just return that reference. What do I mean? What I mean is, you can see this is the very first time. ARR1 is now pointing to this particular array. Okay? So now you can think about system will cache the address of this return value. In this case, just an array. Okay? So now, if you look at this one, this part here, when I say ARR2, a.new once array. So this is now calling the second time. If it is calling the second time, what you will do is you will simply return the address of this array only. You don't try to do anything else. Whatever that's in the implementation body, ignore it. Okay? So now that means what you're going to get is ARR2 is now just pointing to that particular array because you're just storing the reference, right? Just caching the reference. Okay, let's do a little bit more and then I'll take questions. Okay. So after this, you can see that result will just be ARR2, the count will still be 1. However, notice that it's still Alan. Mark is completely ignored. Okay? That is why usually the once routine, you may not take any parameter, usually, because the parameter is only considered for the very first call, okay, typically. Okay? So you're going to see later on when we use the once routine or once query in the Singleton pattern, we don't have any parameter for the query. Okay? Just something to note. Okay, so now you want to see Mark over here ignored because it's passed the first time. Okay, so now finally, notice one thing we said before previously by using the non-once routine. And then the two arrays will just have different references, right? But now, since every time, starting from the second time, you're always returning the same object's address. In that case, ARR1 will be equal to ARR2, it will just be true. Okay? Let me test your understanding a little bit more. What if, let me declare just another one, ARR3, which is array of string. Okay? Let me just insert after this, I'll put it here. What if I say ARR3 is assigned to A, right? Dot new once array. Sorry, I'm running out of space. Let me just make some space for myself. And then let's say Tom. Now, question for you. What is ARR3 going to point to? Yeah, 1, basically aliasing, right? Because it's already past the first call. Doesn't matter which one it is. So now, what's going to happen is Tom will just be ignored. Okay? And then ARR3 is just pointing to this. Okay? So only the first call matters for the implementation. I mean the body of the implementation. Beyond the first call, always return the value of the return value, right? If the return value is a reference type, just return the address. Any question about this? Once routine. It's not too bad, not too bad. So you get a feel about that. Well, I would say you got something similar, but not exactly the same in Java, static. Something similar, right? Similar, but not exactly the same. So let's see a little bit further, and then we'll compare the design also in Java to have some feel. Okay, so now let's go back here. Okay, that's exactly what we just went over. So now let's do a little bit just slides. I'll go over that quickly, but you already have seen all the essential stuff you should know about once routine. So typically, you will simply, that's how you declare that. You'll simply say some routine R, and if you really meant it to be once, you wouldn't put any parameter. That's usually the case, because it will be ignored from the second time onwards anyway. You might have a return type T, and also you put the once. Okay? This might be useful for your either future labs or projects. Okay? Might be useful whenever you want to have some shared data among the classes. Okay, so now, so replaced by once n, only the first time is going to execute. It's going to take some computational time to actually execute the body of the implementation. And then from then on, you just return the result that's being cached. Okay? That's exactly what we just said. In every subsequent call, doesn't matter. Just return the result. So you can think about, maybe for the very first time, it takes about big O of n, or n squared, to execute the result. What about a subsequent call? O1, constant. That's how you can think of it. So what can be the advantage of using this once routine? Basically, you can think about the once routine can help you create a shared data only for the first time. And then all the subsequent call to that particular data is guaranteed pointing to the same instance of data. That's how you make shared data. But we're going to see exactly how it works. Okay. After this, let's see a little bit further. Okay, how does this help us? We'll see. We want to cache the reference to the same shared objects, basically, right? Yes? Ah, very good question. You know, we'll see that. Okay, let me defer your response a little bit. Okay, basically, you will see that not just post condition, because you want to make sure that there's only one instance of that particular data, right? There should be not a second instance even. What you will put is, remember, invariance is more like the post condition for every routine. So instead of putting the post condition for a single routine, you put an invariance. That's what you will see later. I'm glad you asked this question. So the question really was, how can we write the appropriate contract so that such single instance property can be maintained? That's the question. Okay, we'll see that. Okay, so now let's see a little bit more. Okay. Okay, so now let's talk about a little bit Java, right? So, and then we'll use the once routine a little bit later. Now, before I show you Java code, okay? Why don't you guys tell me how would you do a singleton pattern in Java, right? Let me tell you the requirements over here. We can sketch the idea very quickly, okay? Just consider. Here's my requirements. Requirements number one, of course. Oh, thank you. Share data. That's requirement number one, okay? Only a single instance. Okay, number two, we want to have cohesion. I'll tell you what I mean. Cohesion in the sense that you want to separate between data and share access to the data. Okay, and number three, I think these two will be enough, I think. Oh, cohesion simply means consistency. Cohesion simply means if you define a single class, every attribute you include in that class, they should conform to the same idea, the same theme. We wouldn't consider sharing and also data as this coherent concept, because one is about the data themselves, one is about how do you share them. They're orthogonal, they are independent concept over here. Okay, yeah. If you try to put a sharing and also data themselves in the same class, you're violating that principle. Yeah. Mm-hmm. All right, so now just give me a little bit idea. How would you do this in Java, right? R2 simply tells you you may want to have at least two classes rather than a Superman class, right, to actually handle everything. Okay? R1 tells you if you have two classes, that means you want to make sure it's not possible actually for you to actually create more than one instances of the data, R1 and R2. It's a possible. Just sketch idea, you know. Well, I do have both. I got two possible solutions for you anyway. Well, I just want to hear your thoughts. Go ahead.
Can we just call it the idea of once nine in Java? Like, well, just make a class that does that.
Yes, you can somehow simulate, basically. You can try to simulate the once routine in Java. How would you simulate? Yes. Okay, that's good, because the very essence about once routine is you want to distinguish between the very first time you called it versus all the subsequent calls. So possibly you can have a Boolean flag over there to say initially simply false. As soon as you call that routine for the very first time, set a Boolean flag to be true. Something like that, right? Okay, anyway, I don't want to waste too much of your time. Let's see the Java code very quickly, and then we'll criticize on that, right? Okay, let's now have a look at the first version over here. First version. Okay, let me go over that with you. The first version, I tell you that, first version, let me just remind you about, you know what? Let me just copy and paste these two requirements over here so we can remember, right? These are the requirements I give to you. Let's see which one is being satisfied and which one is not being satisfied. That should be good. Is it too small? Should be okay, right? Good. So now, let's go over the classes very quickly. Okay. So now, number one, we have a bank data, and also we got bank data access. This is good. R1 and R2. Are we satisfying R1 or R2? R2, right? Cohesion. Because now we do have one class just about the data themselves. The other one is going to be just about the access. Okay. So this one is satisfying R2. Okay. Check. What about R1? We're going to see. Okay. Let's say we have a constructor over here. Okay. And then we have, let's just make it simple. Let's say we got interest rate. And also we got set interest rate. So now for the bank data access, like what you just mentioned, we're going to have, we have a static Boolean attribute to say, have we initially called that once routine just yet? Have we? Initially simply false. And then we have, so this is the data to be shared. Okay. So this is the data to be shared. Okay? And then we're saying that if it is not the case that we have initialized that once, then we're simply going to create a new instance of that. Agree? Okay, good. Otherwise, return the data. You can think about this is for all subsequent call. Oh, sorry, let me make it more concise, more precise for you. You can think about from these two lines, you know that for the first call, new instance, for subsequent call, in which case you simply return just data. Return just existing data. Okay? So now let's see a very simple tester to see if you might be convinced that it's also satisfying R1. Let's see. Let's say in the client side, we got account over here. So you simply declare bank data. And then you simply say data that we are trying to share, simply say bank data access.get data. Okay? So this is the first call, agree? For the first call, it's going to return back to you data. It's simply going to point to just data, right? Okay. Let's now do another one. Oh, you know what? Let me make it more precise for you. Sorry about it. I shouldn't skip that many steps. Let's say that's the account class over here. If I say account A1 is new accounts. In that way, that means for A1 is pointing to an account over here, ACC, and then one of the attributes is simply data. That data over there for the very first time is going to call new bank data, right? For the very first time. That one is simply going to point to a new data objects. Okay, that's for the very first account objects. What about the second one? If I say account A2, new accounts. So now this is the second time, right? So that means the init once would have been set to true already, right? So that means when you return data, it will just return whatever address it is for this guy here, right? So that means A2 is now pointing to ACC, and that one is data, and we got aliasing. Okay, doesn't matter how many instances you're creating. So are you convinced that are you convinced R1 is also being satisfied? Are you convinced? Well, not quite. Anyone? Yes?
Not quite, because the bank data itself isn't ensuring the sharing, it's the access services.
Aha, good.
Access everything along.
Exactly. I absolutely agree with you. Can you, okay, very good. So this could be a very nice question to ask you to test your understanding. Number one, this is not safe for shared data, simply because it's only if the client is only trying to get the data from bank data access. In that case, you can guarantee everything is going to return a single instance. But what if there's some other potential clients that use the bank data class? Can they create multiple instances? No. Absolutely. No? Yes? Let's see. Maybe you're not sure. I'll take note as a not sure. Okay. So now let's see this. Counter example for you. Let's say we got another, let's say we say bank data. I'm talking about this class here. Bank data, D1 is bank data something over here. So that one will essentially create D1 pointing to some bank data objects, right? What if I try another one, bank data D2 is new bank data? Would that give me the same reference, or it's a different objects? Different, right? Just normal constructor. So now that means D2 is pointing to another bank data. So this tells me R1 may not be satisfied unless you have a way to restrict the constructor to other class. Is it? Make it private. I like that idea. If you want to make it private, well, let me think logically, right? Where do you make it private? You're saying, let's say this. If I simply make this private, that simply means I cannot make this call anymore, can I? Unless I collapse these two classes together. Agree? if I collect these two classes together, it seems to be possible I satisfy, oh, sorry. It seems to be possible I satisfy R1. But am I going to satisfy R2 then? Because it's only a Superman class now. You can see the dilemma here. Either you go for R1 but not R2, or you go for R2 but not R1. That's the problem. Unless you can challenge me with another Java design. But you don't have to challenge me now, that's okay. You can think about it. If you can think about a good solution in Java, let me know. Okay, that's okay. Okay, do you see what the issue is? Okay, for this particular design, it's going to satisfy R2, but not R1. The reason that it does not satisfy R2 is by this particular fragment of code. That's the smallest one to demonstrate. You don't have singleton, because you can have more than one instances of bank data. Okay, design number one. And as you suggested, we try the second one. Okay, so now we have a Superman class over here, which does both data and share data. So now we definitely can achieve R1. Okay, let me again put it there. Again, we have our requirements as we lay out. Okay, R1 and R2. So now for R1, for share data, it's definitely possible, simply because now this particular constructor is now private. That means only bank data class can call this. The only place you can call that, you can see that it's simply just over here. Nowhere external. Okay? That's how we achieve share data part. Okay? But what about R2? That's not good, right? R2, simply no. Because now you can see that just this part alone, oh, sorry, not this part, okay, this part here, be more clear. So this part over here is about the data. On the other hand, this part of your class is about another concern, which is about data access. You're mixing two different concepts in your class. So one thing we may not be able to check for every class you design in your project, but it's a self-check. Every time when you define a new class for yourself, think about, am I mixing different concepts in a single class? Cohesion. Right? That's also a very important design principle. It's not easy to judge, but I would say judge for yourself. Okay? It's more like a design principle here. But for this one here, you're mixing two things together, which is not good. So now, is it possible to have R1 and R2 satisfied simultaneously? Okay, that's a question. Basically, we're going to see how we can use once, but once alone is not enough in IFO. You need something more. Remember we talked about export status? Remember? Okay, I'll give you a little bit of hints. That's exactly how we can achieve singleton pattern in IFO. Okay, just a nicer design because you can achieve sharing and also cohesion. Remember, whenever you say feature over here, you will put, you can put something. For example, so far you see none, right? So usually none will be the easiest one to remember. I simply tell you, it simply means private in Java, right? That simply means private. As opposed to, if you simply say feature over here, but don't put any export status, it's as if you say it's public. However, in IFO, export status allow you flexibility. You can specify some existing class over there to say, only that class can call features within this feature section. That's how we can achieve sharing. Okay, we want to say the shared data can only be called by certain classes. Okay, let's see what we can do. Okay, guys, any question here, over here? Okay, let me draw a little bit concept to you. How can this be used over here? Think about in your data class over here. Let's say we have a class called data, and somehow we have a feature over here that's called a data. Okay, data. Let's say bank data. Okay, let's not worry about how it is implemented. That's not the concern. Okay, let's say we got another class. We want to have the cohesion, so we want to separate them. Okay, another one called data access. And somehow data access is going to implement something using once, right? That's how we handle the sharing. Okay, so now question for you. where should we put export status over here effectively? Somehow, yeah, want to say something? Somehow we want to say only certain class can try to get access to the data, somehow. Let me be a little bit more precise, okay? I'm missing some information over here, sorry. Let's say I'm going to move this down a little bit, okay? And also, I have another feature, another section. And also, this will be the constructor for the data, right? Make feature over here, and then maybe do, and also end, maybe. So now we got two different feature sections, right? Which part should we restrict the access? Make or data? Why not the data? Well, think about data is going to be shared eventually, right? So that means anybody can just get access to it. It's shared anyway, shared. So now that means we're going to put export status for the constructor make, right? So that means only certain class can try to construct a new instance of data. What should that class be? Data access, right? Exactly. Good, 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 good. So now that means we're going to see something like data access. So this effectively solved the R1 and R2 that we talked about before, which we couldn't quite do in Java. Okay, just to note that to you. Guys, any questions? Well, the singleton pattern for iPhone itself is not difficult, but you will just find that somehow the export status once altogether it's kind of bizarre. But I would say it follows some storyline over here, so you want to know about the derivation process. Okay? Any question here before I show you the actual architecture? If you understand so far, you pretty much get a singleton pattern. Yeah.
Just out of curiosity, what if data is shared data, right? That represents, let's say, data is shared data of a system, right? And that system has a bunch of collections. Because shared data would be the client of those, let's say, classes that have those collections. It will hold that data, but then since it's a client, like, and not inspired, it would just be like a class that holds shared data, but does not give away only to data access. That would be the idea.
Yeah, basically, yeah. You can think about the actual class that's holding the data is the data class, right? There's an actual storage of the data. And this class over here doesn't store the data. Somehow, they are somehow referring somebody else to this data. It's a kind of indirection over here. Okay? But we'll see exactly how that goes. But you're pretty much on the right track. Okay, if no question here, let's go a little bit further about singleton pattern. Okay? This time, I'm going to contradict myself. I said usually I should present you the diagram and then the code. Let's do this code first. Okay? Code. But the diagram looks very similar to the code, actually. Similar in this case. Okay, so now we got basically to make you focus. Oh, actually, it's hard to get rid of it. Okay, anyway, can you focus on just the supplier for now? Just the supplier. Okay? First of all, did you notice we're using expanded? Okay? So now, I have a question for you right now. Think about it. You can answer me a little bit later. What would be the advantage of using expanded over here as opposed to non-expanded? And then number two, is expanded so necessary for this singleton pattern here? I have two questions for you. Okay? Let's try, I will go over that in just a moment. Okay? But for now, take expanded for granted. So now let's see this. We have a data class over here, okay, data, and then notice what we're doing here. We're saying that creates, usually we just say create make, but now after create we say only data access can actually call the make. That means only the data access class can ever call this constructor, only that, okay? And also, for the constructor here, we are saying only the data access can call that, right? We just got to repeat twice, okay? In the feature section and also in the create section over here. You don't memorize it, okay? Later on, I think to the most extent, you have to know how to do this yourself. You can always make reference to the slides or to the textbook. That's not a problem. In the exam, maybe I'll deliberately take out the export status and ask you if this is going to achieve the singleton pattern, right? That's also quite obvious for you to see, right? Okay, for the make, we simply got, let's say for this particular example, we simply got only v, the integer, to be shared, only that one. Okay, we can initialize v to be 10, and also we got a mutator command over here to change it to some new value. Data is very easy. Okay, now let's have a look at data access. That's the interesting bit. Okay, now you're very focused. Isn't that amazing? Can you do this on the blackboard? Maybe not, right? Yeah. I can also make it very small. Yeah. Okay, anyway. Okay, let's see this. If you look at that, let's not worry about expanded just yet. Okay? Not yet. Let's say we got this class, data access over here, and then we got data and data. Okay? So now, notice what we're doing. We say once. What's the consequence of declaring this to be a once? What does it really mean? Anybody? Try? It will just return the reference of the data, right? So, yeah, share data, exactly. Basically, once simply means for the very first time you call data, it is going to execute a routine, the body of the routine, which is going to be create, result, and make. You're going to create a brand new data instance, just the first time. For all the subsequent calls to data, just return the reference to that particular first created instance, right? Good. And now, back to your concern, right? Can you see that we have invariance? Can you explain to every one of us, what does that invariant really assert us? Are we trying to say every time when you call data, you simply give me the same data with the same contents? Did you notice my wording? I say the same contents. Does it, or it guarantees something that's even more? What's that? Did you notice one thing here? Okay, another way, another question I'd like to give to you. Let me ask you this. What if I say, alternatively, I say data, tilde, data? Yeah, exactly, because tilde over here is checking for contents, right? It's going to call the is equal feature. Presumably, that's declared and redefined. If you simply say the blue one, data, tilde, data, you only make sure every time I call the data feature, is only guaranteed to give me something, some data that has the same contents. There may be different objects. It could be that the first time I call data over here is simply just going to give me a data objects. Maybe with, for example, 2.3, for example, right? And the second time I call that is simply just going to give me just another data objects and also 2.3. This can easily satisfy the invariance, but this will violate this one over here because they are not the same instance, right? So this part is really important, okay? Some of you may have some confusion over here about this invariant. I want to say that very quickly, okay? The way to interpret this particular invariant is easy. Think about this way. Data over here is one call to the data, and data over here just another call. And we are checking this particular invariant as a post condition for every feature. So we always check to make sure, make a one call to the data, make another call to the data. They should return the same objects, the same object reference. That's how we ensure singleton. Any question about this? This invariant here is very valuable to actually be there to make sure everything is well. Yes?
It's just taking the
Yes, exactly. It's a single equality, right? Let me just, in case you're reviewing the notes later, I should put a cross over here, right? That means this is not good, okay? In case, okay? Don't do the tilde. Tilde could be what's in the exam question to ask you, right? But equals is what you should do, okay? Alrighty, okay? After this, why don't we have a quick look over here, okay? We trace that very quickly. So now let's say we have a test over here, okay? And now we have access. So now let's see how we do things together. Now we got access. Let me be consistent with the color. Access will be of type data access, right? And also we got D1, D2, and data. We hope D1 and D2 eventually should point to the same data instance, right? How do we do it? Now, am I going to have any null pointer exception problem, given that I simply call access.data directly without initializing them? Why is that? Say it again? It's empty? No, no, no. It's even more fundamental than empty. You can see that this no line before, right? I'm calling access.data directly without even creating access. Because it's expanded. Okay, do you see that? Okay, that's a little bit of review from last time, right? So that's how I will show you expanded a little bit last time. It is because this particular data class is simply just expanded. Okay? That's simply, oh, sorry, let me say it again. Let me take it back. It is because we say the data access class itself is expanded over here. That means as soon as you declare D1, as soon as you declare access over here, it will be initialized automatically. That is why you can simply say access and access over here. However, as far as the sharing is concerned, do you really need expanded? Not quite. It's only for convenience. What if I take out expanded? My question for you. Hypothetically, if I take out this expanded, if you try that, it's going to complain in the compiler, right? It say that access was not initialized, so you cannot call that. What you have to do instead is to add a line over here and say create access.make, for example, right? And it's simply because so many other clients are going to get access to this particular data, presumably, right? We want to get singleton access. So you don't want to repeat the red line so often. That's why you just make it expanded, just more convenient. So my point is, the two questions I want you to think about, is expanded really relevant to the logic for a singleton pattern? No, not quite. If not, what's the purpose? It's just for convenience, because we know that so many clients that they're going to get access to the data. We don't just save them one line of typing, basically. Okay? So now in the exam, if we give you, excuse me, in the exam, if we simply give you, let's say, the regular class, okay? Let me tell you what could be on an exam. How about that? Let's say this. Is this going to give me a clean copy? I think so. Okay, and now I do want you to see everything. Okay, so now a potential question for you, okay? And make it bigger. Oh, actually a little bit smaller. That's good. And then let me wipe out everything that's not relevant here. And then I tell you what the question could be. Okay, let's see this. Let's say, easy. Let me just, each color means different alternative, okay? Option number one. If I give you the classes like this, except I say, take this out. Is the red version going to achieve singleton pattern? Is it? No, right? How? Okay, that's good. That's good. And what about the explanation? That's about, it's about sharing, but I want to be more precise, okay? Anybody want to try before I write down my answer? Yes. That's exactly right. Yes, that's exactly right. Okay, so now version number one violates sharing because any clients can create a new data. Okay, that's version number one. Okay, and then for absolute clearness, why don't I just try another one? Okay, another one. Let's say I have data access here. I keep it there. What if, would that be okay? Okay, I heard no. No is a good sign, but why not? How do you violate sharing this time? The previous one, we say violate sharing because any other clients may also call the constructor for the data, right? But now, why would they violate sharing? Yeah, exactly. So now, to be more precise, okay? Let me write it down first. Okay, first of all, this is also going to violate sharing because different call to data gives you different objects. Okay, because you just see every time you create a result. Okay, let me go a little bit further. Okay, let's say you simply try to change this from once to do. Everything still just work. I mean, still compile. That's what I meant. Okay, here's my question. If you simply change from once to do, everything still compile, and then you try to execute the same tester, what's going to happen? Huh? Is it going to? Is it going to break the invariant? That's good. How? Yeah, exactly, right? So now be more precise. If I really change this to do, so that means over here, this is the first time I try to call data, right? So that's the first routine, okay? So now that means, remember after every feature call, we have to check the invariance, right? That's a state diagram that we talk about. So after this, we're going to check access dot data equals access dot data. Is it going to be true or false this time? False, right? Because every time now you call the data over here, it's just going to create a new data regularly because it's due. Okay? So now this is going to be violating invariance. Very good. Okay. Are we okay so far? Okay. Yes, question. Go ahead. No, actually, because as soon as you encounter the first class invariant, everything's going to stop over there because there's something wrong already. Yeah, of course. If you have tilde, sure, it's going to be fine, but that's not good. It's not singleton anymore, right? The invariance over there is really important. They're kind of like a guard, guarding the integrity of your singleton objects, right? Question?
Yes, I just lost at some point.
Where?
So create data access. What the reason you have a create data access make? What's gonna happen? Like removing the data.
Okay. Yes. It's basically corresponding to the first version of Java that we talk about, right? You can review the Java, but this is for iPhone. The first version, illegal version I talk about, if I simply remove these two, that simply means it's just regular how you did it for up to now, right? So that means I can easily, in the test, I can simply call, let's say, creates d1 dot make. I can also say creates d2 dot make. I can definitely do that, even in this particular unit test class. In that case, I think simply just got different objects for data.
So with that line, that only the data access that you make, that's what you're saying?
Yeah, exactly. So the export status we put over there simply says all the features under that section can only be called for that particular export status classes. Yeah. Got it? Good. Okay, guys, one more. So far you got potentially 2 exam questions, right? Okay, let's do one more. One more. What if this is my modification? Let's say let me use orange. Where's my orange? Oh, here, good. Good, I saw that, yes, okay, yeah. So now let's say I simply take this out. And then over here, I'll simply say creates access dot make, assuming that we got a make for access, let's say. Okay, everything compile, but do you think this is going to achieve singleton? Yes. The reason that is, the only contribution here, as far as we can see, is it's only going to prevent you from writing an extra line to explicitly initialize the objects. You only do that for non-expanded type. But for expanded, you will just initialize for you. That's the difference. Okay, so this is still Singleton. Okay? But what's more likely on the exam would be this. I might simply cross this out and also change that to tell that you will just do multiple changes basically in the exam. So I wouldn't just give you one thing. I want you to really understand what's going on. There are so many different aspects for Singleton pattern. I want you to understand completely. Okay? I might simply cross out all the important details and ask you what's missing from the Singleton pattern. Yes?
For the final practice tests or tests,
You mean do we have practice exam for the exam? I would say no, simply because I tell you what's the catch? If we give you practice exam, good for you, but at the same time that will force us to come up with new questions. That can be a little bit non-deterministic, right? We might come up with something easier, but you don't want the other way, right? Yeah. But you know, we'll try to help you, don't worry. For the exam, I'll definitely give you tips. Yeah. But I can tell you one of the things you will definitely appear on the exam, contracts. Number 2, design patterns. It's like saying nothing, right? Yeah. What else, right? Java? No Java. No Java. You don't want me to put you don't want me to put Java in the exam. Okay, so finally. Yeah, Singleton pattern is very easy. That's why we didn't have to spend so much time. I think we already went through this particular example over here. Okay, that one's good. Oh, okay. Okay, so now that's good. Okay, question for you. It's a little question just to check. This one I actually already answered that. Let's say this. In the make feature, if you look at the clients, the account class, okay, you can see under the make, if we add this line, if we simply say create data.make, okay, basically I'm saying, let's say one of the lines over here under the make, I'll simply say create data.make. Do you think it is going to compile? No. If not, why not? Exactly, that's exactly right. Okay, it's a very quick test. It's simply because you can see for here, for the creates, we say that only bank data access can actually create this particular data instance, not any other classes. Okay, that's why if you simply try that in this class, in this particular class, which is not bank data access, you get compilation error. Okay, that's how we enforce. Only a particular data access class can call the constructor. The rest would just be, okay, so this one here is just using the Singleton pattern, just another example on the bank data. I'll leave that to you, just the same, basically identical. Okay. The final thing to go through will be the architectural diagram. Okay, let's go over that very quickly, very easy to understand. And then we talk about a little bit of inheritance. So now, this diagram here, I will try to redraw it using draw.io. This was drawn many years ago. I'll try to update this. But for now, let's just see the critical parts, right? Once I redraw the diagram, I'll let you know, okay? But I should really stick to the draw.io standard. That's for the class, okay? So now, for the Singleton pattern, if you look at the architecture, you can think about we got different clients over here. Every one of them, if they want to get access to some shared data, they don't really get to it directly. It's some kind of indirection. The kind of indirection is we have a data class in the middle, right? The data class, the data access itself is the only way for you to get data, because data is once. Okay, and now the most important part to note is you got this invariant here. Data equals data, right? Reference equality. And then every time if you want to get, let me show you a small detail over here. Notice this arrow over here, which is kind of different from the normal client supplier. You want to take a guess what this arrow really means? Huh? Oh, okay. I'll let you cheat. That's okay. Data, okay? Sorry, not data. Beg your pardon. Okay, first of all, we talk about from clients into this data access, right? I'll give you a little bit hints. If you go back to the previous code that we went over, okay, why don't you look at it's like access. Okay, so now between, I'll draw it here. Basically, we're saying that, let's say this is within a test class, let's say, okay? So now all we have is, we have a test class, which is effective. Oh, sorry, effective. What I meant to draw is plus. And then we have a client-supplier relation over here, okay? Client-supplier. And now it should be access, right? Okay, because the label should be access. And it's pointing to which class? Should it point to data or data access? Data access, thank you, okay? Oh, don't be too surprised. In the exam, we might just give you a small fragment of IFO code, turn that into bound. It shouldn't be too difficult, right? Maybe we'll do some exercise together. In case you didn't catch me, what I said was in the exam, we might just give you a small fragment of IFO code and then draw the corresponding design diagram. It could be possible. I will do some exercise together. Okay. Okay, so this will be data access. Okay, so now notice one thing over here. In this particular design, did you notice that? What's the type for data access? Expanded. So there is a way to tell that the supplier you're pointing to, they're expanded. Okay, so now the one you see in my diagram is simply like this. Okay, that's one way, but I would say I'm going to change that to be consistent. But there's another way in the draw.io. It's simply to make this arrow over here. Let me try to make the arrow over here a little bit round. Here's a different arrow. Okay, that means expanded. That was a minor thing. Okay. Okay, once you see the draw.io, you will see. Okay. Anyway, I want to point that out to you. Okay, so now after this, okay, the most important invariants over here, okay, everything else will just be the same, right? The most important part is to see the indirection over here. Clients do not get to the shared data directly. They go through the data access. That's the main thing. And satisfy R1 and R2. Okay. Ask any questions? Are we okay? Yes, question. In the data access, oh, what are the features you should have? Good question. I would say typically not much. Think about what's the purpose. Okay, the question was, if you look at the data access class over here, okay. Oh, sorry, wrong one. Data access over here. At the moment, you can see the only feature you have is called data. I would say that's pretty much enough. Think about what's the purpose for data access. You want to simply just, anyone who wants to get access to the data, rather than going to data directly, they will go to you and then you return the data back to them. That's it, nothing else. I would say typically you wouldn't put anything else to it, no. But you gotta make sure you put in variants, that's important. Okay, any questions about the singleton pattern? Question? No, not now. Are we running out of time? Okay. Okay, so